Hi, hello all. I am Soumya. I am working as assistant professor in the Department of Artificial Intelligence and Data Science in SNS College of Technology. Today, we are going to explore the correlation analysis, a fundamental concept in data visualization and statistics. Correlation helps us to understand how two variables are related. Think of it as a way of asking, when one thing changes, does the other change too? By the end of this session, you will know not only what correlation means, but also how to measure it, visualize it, and use it in a real world problems. Let's we see what is correlation. Correlation tells us about the direction and strength of a relationship between two variables. For example, if the number of hours you study goes up, usually your exam marks also go up. That's a positive correlation. But if the number of hours you spend watching TV goes up, your exam marks may go down. That's a negative correlation. And sometimes two things are unrelated like shoe size and exam mark, that is no correlation. So correlation is simply the story of how two variables move together. Then types of correlations. Let's explore the three main types. First one is positive correlation. Both variables increase or decrease together. For example, as your height increases, your weight usually increases. Then second one is negative correlation. When one goes up, the other goes down. For instance, as the speed of a car increases, the time taken to reach the destination decreases. Then third one is no correlation. When there is no logical pattern. For example, your shoe size has nothing to do with your exam marks. A fun way to remember correlation is like friendship. Some friends always stick together, that is positive, and some always pull apart, that is negative, and some are just strangers, that is no correlation. Correlation coefficient. To measure the correlation numerically, we use the correlation coefficient, that is represented as R. If R is equal to +1, the relationship is perfectly positive. If R is equal to -1, the relationship is perfectly negative. If R is equal to 0, there is no relationship at all. In real life, you rarely get perfect values like +1 or -1. Most correlation falls somewhere in between like 0.6 or -0.3, showing how strong or weak the relationship is. Then correlation analysis techniques. Now correlation is not one size fits at all. We have different techniques depending on our data type. First one is Pearson correlation. It works for continuous numerical data. For example, height and weight. Then second one is Spearman rank. It is used when we deal with rankings or ordered data like movie ratings. Then third one is Kendall's stew, is handy when we have small samples or ordinal data. Then fourth one is correlation matrix, is powerful because it lets us see the relationship among multiple variables at once, often in a table or a heat map. Think of these as different tools in your statistical toolbox. You pick the right one based on your problem. Then correlation displays. Numbers are useful, but visuals tell the story better. A scatter plot shows you how two variables are related with the dots on a graph. Then second one is heat map. A heat map is great when you want to see many correlations at once using the colors. For example, in data science, a heat map can show which customer behaviors are most related to sales. And third one is matrix table. A matrix table gives you the precise numerical values for multiple correlations. In practice, we often start with the scatter plots, then use the heat maps for deeper analysis. Best practices in correlation analysis. When using the correlation, keep these golden rules in mind. First one, always start with a scatter plot. It gives you a visual feel for the relationship. Second one is watch out for outliers. A single extreme value can mislead your results. Third one is don't confuse the correlation with caution. Just because ice cream sales and drowning cases are positively correlated doesn't mean ice cream causes the drowning. The hidden factor is summer heat. Fourth one is use the right technique depending on your data type. Pearson for continuous, Spearman for ordinal, and so on. Let's close with the two quick examples. Study hours and exam marks R is equal to 0.78, a strong positive correlation. Age and social media usage, that is here R is equal to minus 0.65, a strong negative correlation. So to summarize this topic, correlation tells us how two variables are related. The correlation coefficient all ranges from -1 to +1. There are different types, positive, negative, and none. We can visualize the correlations using scatter plots, heat maps, and matrices. Understanding correlation is like finding the hidden patterns in data. Is the first step toward the deeper analysis and smarter decision. Thank you for listening. I hope this session helped you not just memorize definitions but also understand the correlation through the real life examples. Next time you look at the data, try asking yourself like, do these variables move together? If yes, correlation is at play. If not, correlation is not there. Thank you for watching.